Neil deGrasse Tyson. Betelgeuse just exploded and something terrifying is happening. Hold on tight, because Betelgeuse, the colossal red supergiant, has just exploded in a cosmic spectacle of unimaginable proportions. But that's not all. Something utterly terrifying is happening in the aftermath of this cataclysmic event. The repercussions are reverberating across the cosmos, and we're here to uncover the chilling truth. Could this explosion be a harbinger of doom for our own planet? Is humanity in danger? Since 1604, astronomers have eagerly awaited the next naked-eye supernova in the Milky Way. The anticipation stems from the fascination with witnessing the extraordinary event and studying its aftermath. The year 1054 marked the observation of the brightest supernova in recorded history, which resulted in the formation of the Crab Nebula, pulsar, and supernova remnant. Betelgeuse, a red supergiant star located nearby, has become a significant point of interest in the search for the next supernova. Although other red supergiants like Antares and Vi Canis Majoris are larger and potentially further along the path to becoming a Type II supernova, Betelgeuse still holds promise, being the first star beyond our Sun to be resolved as more than a point of light. Betelgeuse's final evolutionary stage has captured the attention of astronomers. The quest to witness the next naked-eye supernova in the Milky Way continues, as the unpredictable nature of these cosmic explosions leaves scientists eagerly waiting for the next spectacular event. The relatively young age of 8 to 10 million years, Betelgeuse, a red supergiant star, is already in its final evolutionary stage. This means that it is approaching the end of its life and has undergone significant changes throughout its existence. The core of Betelgeuse is where elements such as carbon, neon, and oxygen fuse together in layers, generating immense energy. Surrounding its core, Betelgeuse's outer layers exhibit tremendous variation in size, temperature, and brightness. The star's enormous size, exceeding even the extent of Jupiter's orbit around the Sun, contributes to its volatility and unpredictable behavior. Scientists have studied the interior of red supergiants like Betelgeuse to understand their evolutionary processes and anticipate their ultimate fate as Type II supernovae. While Betelgeuse may not be the largest red supergiant star in existence, its proximity and the knowledge gained from observing its behavior make it an essential candidate for studying the final stages of massive stellar evolution. When Betelgeuse exhausts its core's nuclear fuel, it will undergo a Type II supernova, resulting in a dramatic explosion. This final pre-supernova phase, known as silicon burning, is a critical stage in the evolution of massive stars like Betelgeuse. During this phase, elements such as iron, nickel, and cobalt are formed in the star's core. The process is so intense that it generates detectable antineutrinos, which are elusive particles that carry away a significant portion of the core collapse supernova's energy. While the electromagnetic output of the star remains relatively unchanged, the spectrum of neutrino-antineutrino energies experiences a crucial shift as the star approaches its ultimate fate. Detecting these antineutrinos can provide important insights into the internal processes of the star during its final moments. However, the generation of antineutrinos only provides a few hours of advance warning before the actual supernova explosion occurs. Studying this phenomenon is crucial for understanding the life cycles of massive stars and the release of energy and particles during these cataclysmic events. During Betelgeuse's supernova explosion, Earth's neutrino detectors will be flooded with several millions of neutrinos. Neutrino and antineutrino detectors consist of large targets inside tanks surrounded by photomultiplier tubes. These detectors allow scientists to study the characteristics of neutrino interactions and provide valuable information about the events occurring at the source. The intense burst of neutrinos produced during a supernova can be captured and analyzed to gain insights into the physics of the explosion and the processes taking place within the collapsing star. Neutrinos are elusive particles that can travel through vast distances and penetrate matter almost effortlessly, making them ideal messengers to study the inner workings of such cosmic events. The detection of these neutrinos not only confirms the occurrence of a supernova, but also offers a unique window into the extreme conditions and particle interactions happening during the stellar collapse. By examining the neutrino signal, scientists can uncover valuable clues about the nature and dynamics of supernovae, contributing to our understanding of stellar evolution and the universe as a whole. The timing of Betelgeuse's supernova remains uncertain, with the event potentially happening anytime between tomorrow and approximately 100,000 years from now. The exact moment of a star's explosive demise is unpredictable, making it challenging to determine when Betelgeuse will reach its critical stage. Astronomers continuously monitor the star's behavior and search for clues that may hint at an impending supernova. The dimming and rebrightening episodes experienced by Betelgeuse in recent years have added to the intrigue surrounding its fate. In 2019-2020, the star underwent a significant dimming event, only to rebrighten later. Since mid-April 2023, it has further brightened and surpassed the brightness of several other prominent stars in the night sky. This unexpected behavior has piqued scientific interest and led to speculation about the current state of Betelgeuse's interior. While the possibility of Betelgeuse going supernova in the near future cannot be ruled out, the exact timing of this celestial spectacle remains a mystery, reminding us of the unpredictable nature of astronomical phenomena. The red supergiant star Betelgeuse underwent a dramatic occurrence in 2019 and 2020 that captured the attention of astronomers and sky watchers all across the world. It passed through a phase in which its brightness was reduced to roughly 1/3 of its typical intensity, and this phase lasted for some time. Betelgeuse, on the other hand, took astronomers by surprise in April of 2020 when it suddenly re-brightened and returned to its normal range of brightness. It was determined that the star had temporarily dimmed its brilliance due to a big burp of material that it had emitted, and this was the cause of the dimming event. The ensuing brightening gave astronomers a sense of comfort while also piquing their interest in Betelgeuse's behavior, which they had been attentively monitoring. Since the middle of April 2023, the star has been going through an abnormally brilliant period that has lasted for an extended amount of time. As a result, it has gone beyond its typical range of brightness and has become the 7th brightest star in the sky. Betelgeuse's interior has been the subject of much conjecture and inquiry as a result of its brightness that has persisted for such a long time and increased in intensity. Betelgeuse's mystifying nature and captivating attraction in the night sky are further enhanced by the fact that researchers are avidly continuing their observations and research in an effort to decipher the secrets that lie behind the intriguing changes in the brightness of the star. When Betelgeuse finally goes supernova, it will release a massive amount of energy, which will ultimately result in an explosion that enriches the interstellar medium in its vicinity with heavy metals. This process is eloquently demonstrated by the remnant of SN 1987A, which demonstrates how the material from the dead star gets recycled into the interstellar medium. The explosion not only releases light, but also produces detectable neutrinos, providing a multi-messenger approach to studying supernovae. With the functioning of the LIGO and Virgo detectors, the next supernova within the Milky Way may yield a triple multi-messenger event, including particles or neutrinos, light, and gravitational waves. Neutrinos play a crucial role in this multi-messenger approach, offering a unique insight into the core collapsed supernova's energy and dynamics. The detection of neutrinos from a supernova can provide valuable information about the inner workings of the explosion and help refine our understanding of the processes involved. By combining data from neutrino detectors, observatories, and gravitational wave detectors, scientists can paint a comprehensive picture of the cosmic event, enhancing our knowledge of supernovae and their impact on the surrounding universe. The occurrence of supernovae is a natural and inevitable phenomenon in the life cycle of stars, but the exact timing of when they will happen is highly unpredictable. One such star in our galaxy that holds the potential for a supernova is the Wolf-Rayet star WR31A, located in the Carina constellation. This massive star, situated about 30,000 light-years away, is expected to explode in a supernova, enriching the surrounding interstellar medium with new and heavy metals, similar to WR124. Determining which evolved massive star in our galaxy will be the next naked-eye supernova remains a mystery that can only be unveiled with time. The complex processes and intricate balance of forces within stars make it difficult to pinpoint exactly when they will undergo a cataclysmic explosion. While scientists continue to study and monitor potential candidates like Betelgeuse and WR31A, only the passage of time will reveal which star will be the Milky Way's next awe-inspiring supernova, captivating astronomers and sky watchers alike. And that's pretty much it for this video. Want to watch more? Then hit the subscribe button.